In example 7, we have to solve this trinomial x to the fourth minus 5x squared plus 4. And when we have to solve a polynomial, the best way to do that is to factor if we can. Now, the thing that is different about this problem, and scary sort of sometimes about this problem, is that it's not necessarily what we're used to, meaning that it's not just an ax squared plus bx plus c, where we have a leading term as an x squared. The leading term this time is an x to the fourth. But the good news is that we really factor the trinomial the same way. There's just one step that's different, and I'll show you that in just a bit. But I'm going to start off the same way, trying to factor it. I'm going to look for a GCF first, and there's not a GCF. So now I go straight to rooftop, where I multiply the first term and the last term together, meaning that I multiply 1 and 4 to get 4. And I'm going to go ahead and write a statement. I'm going to say I need to find two numbers that multiply to give me 4, and they need to add to give me a negative 5. Well, I'm going to determine the signs real quick of these numbers. See, if I'm multiplying to get a positive number, that means my signs are the same. But if I'm adding the two numbers to get a negative number, then they both have to be negative. Okay, because two negative numbers do multiply to give me a positive number, but they add to give me a negative number. So the factors of 4 are 1 and 4 and 2 and 2. So I'm going to make these negative, and I'm going to see which ones work, if any. Negative 2 and negative 2, they do multiply to give me 4, but they add to give me negative 4, and that's not negative 5. So I scratch that. Negative 1, negative 4, they multiply to give me 4. They add to give me negative 5, so that works. Here's the thing that's different. I am used to putting just an x in the denominator and simplifying. Well, I did that because x times x would give me x squared. But I don't have x squared this time, I have x to the fourth. So instead of putting just x in the denominator, I'm going to put x squared in the denominator, because x squared times x squared gives me x to the fourth. So now I try to simplify that, and it doesn't simplify, so I put the bottom in front, bottoms up. X squared minus 1, and then x squared minus 4. Now notice here I got two binomials that are quadratics. Looks like they're differences of squares. So I'm going to have to factor each one of those binomials. We got a perfect square and a perfect square here, so I'm going to say plus and minus, and I'm going to take the square root of the front and the back. The square root of x squared is x. The square root of 1 is 1. And I need to try to do the same thing back here. Looks like it's a difference of squares as well. So the square root of x squared is x. The square root of 4 is 2. And this thing is fully factored. I can now solve it, and all I want to do is set each factor equal to 0. X plus 1 equals 0, and x minus 1 equals 0, x plus 2 equals 0, and x minus 2 equals 0. And right here it's really simple to solve for x. All you gotta do right here is subtract 1 from both sides and get that. X equals negative 1, and right here we're going to get that x equals positive 1, x equals negative 2, and x equals positive 2. Now the way you would probably type this into the computer, the computer would probably say something like x equals, and it would give you a box, probably, and just in that box you would type in negative 1, 1, comma, negative 2, comma, 2. Now, notice there are 4 answers here, and that makes me feel good because the degree of this polynomial is a 4th degree. That's the highest degree in it, and so that means you're going to have 4 answers.